Welcome to Bungalows for Bachelors. We are now ready to take a shot at proving that the layout of all of our panels, the spacing, the locations, all of that stuff is good by the International Residential Code. That is what we are trying to prove here. If we can prove it, then you can do it. If you can prove it, then we are good to go and we can know that when we continuously sheathe our house and we check these locations that make sure these things are all in here, then we know our house is good. That is the whole point of this. So how do we prove it? Well, there are minimum requirements of how much bracing length is required to be in a braced wall line based upon the distance from one braced wall line to the next one. This is braced wall line A. It's 12 feet 8 inches away from braced wall line B. So based on that distance, there's a table in the International Residential Code that's going to tell me a required bracing length I need in this wall and in this wall. So let's get into that. Now I happen to know I'm going to design for 115 mile an hour wind just because I selected it. And over here, I copied some values from the table that are going to help us do our math here. So what you see on the first column is feet. That's a distance. So what is the distance between two braced wall lines? If it's 10 feet, then you need 3.5 feet of let-in bracing. So if you're going to use the method let-in bracing, then you're going to select that value. But if instead you're using continuous sheathing wood structural panel, then you're going to use this value. You can use either one, or you can use a combination of the proportions of both. So I need, let's say I have a 10-foot spacing to my wall, and I have a let-in brace, and I have a continuous sheathing wood structural panel in my wall. I mixed my methods, which is fine. Then what I need to do is prove that I at least have, I need 100% between these two methods. So I need 3.5 feet of let-in brace and 2 feet of continuous sheathing wood structural panel. If I, let's say, make it easy to go 50%. So if I do 50% of 3.5 and I know I have that length, and 50% of 2 and I know I have that length, then I technically have 100% of my requirement. So I'm good to go. For our case, braced wall line A has only continuous sheathing wood structural panels on it. So we're going to use that number. All right. So 12 foot 8 is the distance between it and the next one. So I'm going to check this first brace wall line. 12 foot is somewhere between 10 and 20. I'm going to round up to 20 because I happen to know that I only need 3.5 feet in my situation. So I've got almost a 3-foot panel in 2 places and a 4-foot panel. So I've got lots of length in my wall. I have, let's see, that's almost 10 feet of length of panels, total length of panels in that wall. And I only needed 3.5. Yeah, 3.5. So I got plenty. Now, it's important to remember, we can't just stop there. It's important to remember that the numbers in this table have been derived from a bunch of assumptions about a house. Some important assumptions about the house that were made for this table were, let me find a place to draw it over here. It assumed a few things. It assumes this first, 10-foot ceilings. That looks like a 6, but it's a 10. 10-foot ceilings, and it assumes, I forget the number, don't quote me on this, but it's something like a 33-foot, that's an inch mark. It's something like a 33-foot mean roof height or something of that sort. So that's the mean roof height it's assuming. Now, the mean roof height matters because if I have a taller roof, I'm collecting more wind pressure, which means I need to resist more wind pressure in my wall panels. Okay, so that's why that matters. So that these numbers came from assumptions, and we're going to deal with how to correct for those assumptions right now. I have created a document in Excel to calculate the factors for you that will adjust if you deviate from that standard example. So the way we're going to use that is we're going to pull it up here, and we're going to first want to know what's the length we needed in the beginning. So we rounded up to 20 and we said we needed 3.5. Okay, so remember that number, 3.5 feet, and remember the design of the house. Okay, we had 8-foot ceilings everywhere except this front wall, which means 8-foot walls everywhere except this front wall. And our roof height was the peak was 5 feet above our wall, which means the mean roof height would be the halfway point up the roof. So 2.5 feet plus the wall height, give me 10.5 feet. So remember some of those numbers. And we'll go explain the chart now. So this is how we use the calculator. First, we're going to know the gray boxes are all input boxes. That's where we want to put our numbers in. We don't touch anything else. It will do all the math for us. So what is the required length? In this case, 3.5 feet. So put that in, it's already there. What is the number of stories? This is a 1-story. Exposure category B, C, or D. What you basically need to know here is exposure category B is typical urban building. So if your house is going to be surrounded by other houses, or your house is going to be surrounded by a bunch of big trees that are sort of relatively the size of houses, and the wind is going to be broken over those trees or houses, then the wind will be slowed down. And when the wind is slowed down, then your house is not loaded as hard. So that's the important part of why this matters. Exposure categories C and D are cases where your house is going to have wind speed up effect on it. So if your house is next to a hill or on a lake or in an open area where the wind will speed up, then you need to account for that basically. You're going to have a harder wind load, even though your design wind speed is the same. So if you need to differentiate exactly between C and D, which one's which, you can always just Google exposure factors for wind and it will explain it for you. I don't honestly recall the different. So if you need to differentiate between C and D, you can look up the difference and select for it. Otherwise, for most cases, we're going to use exposure category B. I'm going to, let's say, build this thing around a bunch of trees. All right, so that's going to give me some item 1 factor of 1 here. It's going to just do that for me. Item 2, roof eave to ridge height. This is the distance from the top of my wall to the peak of my ridge. On my house, I happen to know it was 5 feet, so that's why there's a 5 in here. And then here, we are either holding the roof only, we're holding the roof into floor, or we're holding the roof in 2 floors. All right, so make sure there's only a 1 in one of these boxes. If you put it in anything else, it will give you error. It's been debugged for that. So make sure you either have a 1 and the others are empty, or there's zeros. Empty is fine. All right, so in our case, we're not holding any floors. It's a single story, so we're just holding the roof. So I'm going to put a 1 there, delete that one. That's going to give me that factor. Item 3 is the story height. This one's pretty simple. In the wall we are designing, which is that rear wall of the house, brace wall line A, what is the height of that wall? It's an 8-foot wall, so I'm going to put number 8 here. You want to do this factoring for every single brace wall line you check. Item 4, number of braced wall lines per plan direction. All right, so I'm going to look at what is the direction I'm designing for. It's from the right or the left. I'm going left, right here. So how many braced wall lines do I have? I have 1, 2, 3, 4 braced wall lines. So I'm going to make sure that number says 4. Good to go. All right, items 5 through 8 are essentially extra things that are usually not applied unless you have special situations. Item 5 is use 800-pound hold down device for each panel. So if you want to install hold downs and special anchors on all the panels in your plan, then you can say yes to this, which would be a 1 for true, and it will require less strength by making a smaller factor, 0.8. At the end of this whole thing, we're going to take this total factor, we're going to multiply it by the original required length, and it's going to give us our new required length based on our more updated information for what we're designing. Okay, but I don't want to do that because that's a pain in the butt. So we're going to make that a 0. Leave it as 1. Item number 6, gypsum board not installed on the inside face. So this is a rare case, but if you are building an unfinished garage or an unfinished basement or an unfinished detached garage, whatever it may be, and you're doing this wind design, you need to understand that the original wind design CSWSP that we're using in our house here has been anticipated that there will be sheetrock on the other side of that wall, not just a OSB or plywood panel, but there's also sheetrock on the other side, and that's contributing to the strength. So if you neglect that and you leave it out, you got a factor for it. So when we make this true, you see this number goes up. Above 1 means that we're requiring more. So we don't want to do that because we have a regular house here. Item number 7, nail gypsum board at 4 inches on center on the edges and all edges blocked. So this would be rarely done because first of all, you got to convince your drywall contractor to use 4 inches on center all over the edges of the sheetrock, which is a lot of hardware and time versus the 7-inch on center standard. So there's that, and all edges have to be blocked. That is important because when you block the edges, you're basically adding more strength to all the panels. You're adding more strength to the wall system. So if we were to do that, we're only requiring 0.7 now. So we require even less strength because our sheetrock is adding more strength to our walls. But that's a weird thing to do, so we're not going to do it. Item number 8, horizontal blocking has been omitted. So if I don't horizontal block my sheathing panels, I have to double how much panel I need, basically. I have to double my strength. Now, I'm going to go back here and draw. The reason that's important is if I have a wall, let's keep going. If I have a wall of studs, like so, most of the time, you're going to install your panels. It's going to be a standard height, 8 foot, 9 foot, 10 foot, right? You're going to get a full height panel. You're going to install, let's say these are 16-inch center studs. You're going to cover 3 of them. Well, 4 of them technically, 3 spaces. And what's going to happen is you're going to get nailed to the top plate, the bottom plate, the stud, and the stud, all without any blocking. All edges of this panel have been installed straight onto wood. So there's no problems here. Now, that matters because in terms of building stresses, when the wind load is applied to the side of the house and this panel is being stressed, what's going to happen is in this direction, it's going to have compression right here on that side of the panel. It's going to have tension on that side of the panel. And the panel connection, oh man, I don't remember the panel connection to the plate is very important up here, and the panel connection to the bottom is very important right here, right? Because that's where all the loads are being transferred. It needs to be connected to all places in order for this panel to do its job. So, oops, I drew an arrow in the wrong direction. So these are in compression, these are in tension. That was a silly thing. Being pulled. Oh, no, it's not red, whatever. Okay, so if I were to install a panel like this instead, then let's follow the stressed loads. Let's follow the areas of pain for the house, right? Same wind situation. Now we have a bunch of, we got wood, where we're nailed to wood here. We're nailed to wood all the way through here. We're nailed to wood all the way through here. But oh, look, all the way along this top edge, our sheet is just floating in the air. It's not secured. So the reason we block all of those unsecured edges is to properly account for all the strengths and stresses that are going to pass through. Now, if we block for it, and of course we have another panel up above it, right? If we block for it, then it's all the same. The wall does not care what is what. All the loads are going to be transferred through. So it doesn't matter necessarily which orientation you put it in, as long as all those joints are blocked. and the blocking is taking something the same size as the stud in a little piece and putting it in the wall, if that was not clear. So that's why this one matters, but we're not going to do that. Now we can apply these special rules if we have a special case and need to play with the numbers basically to get a design to work in a tricky situation. But most of the time we're going to leave those alone. All right, so all these are now set good. So now my total factor was 0.91 and I only required 3.2 feet. So when I go back to my design, I only needed 3.2 feet actually in this whole wall, not 3.5, because I factored for a more correct version of my house from what this table's standards are. All right. Now we got to do that for every wall. Now I happen to know all of these are going to change. The only thing that's going to change between my walls is when I switch to doing this vertical direction, I will switch to only needing 2 brace wall lines, which is going to make it even easier for me. And this front wall, I'm going to switch and make the wall height taller because this is a balloon framed wall. It is taller than an 8-foot wall. So those are the only situations where it changes because I'm just familiar with what these factors are, and these factors don't change. Like the wall height can change usually, braced wall line number can change, but usually the the ridge height does not change. And your exposure category is just the whole house thing, so that doesn't really change. All right. So that's how we do that. So let's move on through here. So brace wall line A is good to go. I don't need to do anything. I happen to know that this all works. If I wanted to, I could write out my required length and my actual length and prove that I'm good, but I don't care. I'm way over designed. Braced wall line B. Okay, so I've got a leaden brace and a leaden brace. And here's what I need to do here. Because this is a middle wall, and what I mean by middle wall is that I have a distance on the top of it and I have a distance below it. So what I need to do is I need to add the requirements from both of them. I need to treat these like they're each separate building. So if I were to do this, I'm basically treating this block like it's a building, and I'm treating this block like it's a building. Okay, and because this wall is holding both buildings, I need to add the required strength from both sides. So I've got a leaden brace as my method. I've got a 12-foot 8 and I've got a 20-foot 10. For the purposes of time, I'm going to round this down to 20 feet and round this one up to 20 feet. I happen to know you shouldn't round down because that means you're under designing, but I happen to know that I'm rounding up a bunch on this side, so I'm not really under designing. So I got two 20-foots and I'm using leaden brace. So that means from one of the sides, I need 6.5. From the other side, I also need 6.5. So I need a total of 13 feet. What do I have? Well, I have an 8-foot one here and a 7.5-foot one here, which gives me 15.5 feet, which is more than 13 feet. So I've got tons of bracing. I'm good to go. I meet our requirement. And that's before I've even factored it. I happen to know that my factor is below 1 because of all these things. These things did not change. My factor is below 1, so I know I require even less. Therefore, I'm not even going to bother with the math and my Excel calculator. I'm just going to know that I'm good. All right. Now, brace wall line C, we're going to apply the same principle. I've got 20-foot 10 and 16-foot 2. So what I'm going to do to prove this one is I can't round as generously. I'm going to try to be more exact with my math to know that I'm good. So what I'm going to do is I'm going to say 21. So I'm going to round this to 21 feet, round up, and I'm going to round this one to 16 feet. I'm going to round down because I'm rounding about the same amount, so it's not going to make a huge difference. Okay, so got 21 feet and 16 feet. How do I know exactly what I need? Well, you are allowed to interpolate the values in these tables. So if I have a number that's between 10 and 20, I'm allowed to interpolate these numbers the same ratio and find the required length between those. So I've got a 16 and I've got a 21. All right. So I need to add the required length from both of those, required lengths from both of those, get a final number, factor that final number, and see if I make it. All right. So I could do some equations and fancy stuff to show you how to do this interpolation thing, but instead I'm going to tell you a story because that might be easier to remember and the method might be easier. All right. So here's the story. There's a little bunny named Foofy, and Foofy the bunny needs to go from his first investment property A to his second investment property B. And he had to travel 10 miles to do it. And he had to travel 10 miles because his first investment was located at a mile marker 10 and his second one was located at mile marker 20 on the side of a highway. Sure. All right. So he had to go the difference between these 2 points, which was 10. But he wanted to stop at the ice cream store, which was at mile marker 16. So instead, he only went 6 miles, right? So if he only went 6 miles out of the 10 miles that he could have to get to his investment property B, then he traveled 60% of that distance that he needed to go. All right. Now, if I take this 60% principle and I apply it to the same trip from 3.5 mile marker to 6.5 mile marker, well, the difference between those was 3 miles. So he was 3 miles apart from investment property A to investment property B. And so I need to know 3 miles, but he only went 60% of it because remember he had to stop at the ice cream store. All right. So 0.6 is the decimal equivalent of 60%, is going to give me some number. I happen to know that's 1.8. All right. So he went 1.8 miles past the mile marker 3.5 in between 3.5 and 6.5. Okay. So I need to know what that number was. What is 3.5 plus 1.8? That gives us 5.3, assuming my mental math is good, because that's 4 and that would give you 13. Yeah, so 5.3. Okay. So I know the equivalent lead and brace required length of the 16-foot mark is 5.3. Okay, so I'm going to apply the same story between 20 and 30, except this time Mr. Bunny Fifi, or Foofy, whatever his name was, only went 10% because it was 10 miles to get to 30 and he only went 1 mile in. So I'm going to go 10% from 6.5 to 9.5. The distance is 3 between the two of them. 0.1 is 0.3. All right, so now I have 0.3 is the number I need to go past 6.5, which gives me 6.8. All right, so 6.8 and 5.3 are my required lengths from this standard table. So I'm going to go factor that and see what I need. 5.3 and 6.8. So I'm going to go into here. I'm going to type equals 5.3 plus 6.8. I get 12.1. All right. I know none of these factors change, so I'm going to go down to the bottom, and I need 11.05 actual required length. I'm going to go back, and I'm going to look at what I have. I have 11 feet 5 inches, so I have more than 11.5 feet. I know I'm good. Now, I happen to know that this one needed to be calculated as exactly as possible because I barely had enough to prove that I'm good. So when I know I have a bunch extra, I'm going to make my math quicker and just overestimate a bunch of stuff and know that I'm still good anyway. But if I'm cutting it close, then I'm going to be more careful and methodical. So I know that one's good too. And braced wall line D. All right, so let's do this one. I have a 16-foot distance here. I'm going to round up to 20-foot distance because I know I've got room. 20-foot distance requirement for continuous sheathing wood structural panel is 3.5 feet. However, this front wall is taller than an 8-foot wall. At the peak, it is a 13-foot wall. So I'm going to just kind of average and say 10.5. I'll round up to 11 foot. So it's an 11-foot wall because the wall is a varying height. So I'm going to change this factor to 11, and then everything else is the same. And I needed 3.5. So the bottom number is, I see my total factor is above 1, which means I'm requiring more than normal. So I need 3.73 feet. Go back to my plan. I already have a 4-foot panel here plus more, so I know I'm good. So I am good in the right-left direction. I know I don't need to do anything else in terms of proving those distances. Now I'm going to go the up-down direction. I have brace wall line 1 and 2. They're 15 feet apart. I'm going to round up because I know I have tons of wall to work with. I need 3.5 feet of continuous sheathing wood structural panel in each wall. I know I've got 1, 2, 3 panels here. These two are 4-foot panels. So I've got plenty. On this side, I have 1, 2, 3, 4 panels, and they're all 4 foot. So I have 16 feet. I got tons and tons. So this one's not even close. I'm not even going to bother factoring because I know I have tons and tons extra. And if I needed more, I would just claim more because I've got tons of clear wall. I could add more panels. All right. So that's how I know my lengths are proven to be appropriate and sufficient for design. Okay. Now, the last thing I'm going to check here is the end conditions. So, brace wall line A. The beginning is this panel, the end is this panel. I'm going to check both ends of the brace wall line, and I'm going to want to know if the end condition is good. Or not good, but if I need to make a modification. So there's a set of questions I'm going to ask to do this. So I'm going to start on this end. Look at this panel. The first question I'm going to ask is, do I have a full 4-foot panel on the end of my wall? If the answer is yes, then I'm done. I'm not going to ask any more questions. I'm good. Over here, I'm going to ask, do I have a full 4-foot panel on the end of my wall? The answer is no. So I'm going to continue asking questions. The next thing I'm going to ask is, do I at least have a 24-inch panel? Yes, I do. Okay. And the next thing I'm going to ask is, do I have at least a 24-inch return panel? This is the return panel. It's referring to the wall that's butting into the corner. Usually there's a corner. If it's like an intermediate wall, like this one, I would consider this a return panel. The return panel is going to terminate at that intersection. Well, this one's not quite a return panel because it's sort of offset, but I would line it up if I wanted a return panel. Okay, so that's my return panel. Is that one at least 24 inches? Yes, it happens to be a full 4-foot panel. Okay, so if I have a 24-inch minimum return panel in the corner and a 24-inch return panel minimum on the other side of the corner, then I'm good. I don't need to do anything else. All right, so that one's good. Brace wall line B. End condition. I've got more than a 4-foot panel and I've got more than a 4-foot panel. I'm happy with that. Brace wall line C. I have more than a 4-foot panel, and technically my brace wall line ends right here. And I don't have a 4-foot panel where the end of my theoretical brace wall line is. All right, technically there should be a dashed blue line all the way through this house. I don't have a 4-foot panel here, and I don't have a return panel. So I can do one of two things. I have space where I could put a return panel, or what I can do is add, ultimately what I'm trying to figure out is, do I need to add an 800-pound hold down device to right here at the end condition of my last panel? Okay, so this panel over here, this lead brace is the last panel in my line, technically, because it's doing the 10-foot distance rule from my end. So that's my last panel. If I don't add a return panel, I've got nothing on the other corner. I got nothing there. I will add an 800-pound hold down device to that spot to restrain that panel. But that's always a pain because now I need to like get this bolt in the right spot and do this anchoring situation or dowel into the concrete, whatever, and that's a pain. So I would rather claim my return panel trick. I'm going to put another 4-foot panel right here. All right. So I do that and I know I'm good. I'll add the label here. Oops. And hunky dory. Great. Good to go. All right. So that's my end condition. Good there. All right. Brace wall line D. The first panel. Oh, so I'll start on the left side for consistency. All right. Here's a tricky one. Do I have a 4-foot panel on the end? No. Do I have a return panel? No. Well, then I'm pretty much stuck. My first panel is following the 10-foot spacing rule, and I have no return panel. So on this one, I actually have to install an 800-pound hold down device on the end of this panel in order to have a proper end condition for my wall. This side of my wall, I do have a minimum 2-foot panel. It's not 4 foot, but I got a return panel, and it's more than 2 foot, so I'm good to go. It's going to hold that corner down. The reason we care about the return panel is because this panel is going to add rigidity and strength to the corner as well as this panel on this wall. That's why I'm accounting for the other wall, even though it's not the same direction. Okay, so that's all the left-right directions. Let's do up-down directions. Okay, braced wall line 1. The first panel is right here. It's a full 4-foot panel, so I'm going to move on to the end. There's no 4-foot panel on the end. There's no small panel, and there's no return panel. I got the same problem. And this panel is it's following the 10-foot rule away from the wall. So I need an 800-pound hold down device right there. It's going to hold this panel down. Well, it's going to be inside the wall, but it's going to hold that end of the panel down. All right. Let's go over to brace wall line 2. I happen to know on this end, I have a full 4-foot panel. And on that end, I've got a full 4-foot panel. So that one's easy. Done. Okay. So the reason I check end conditions is because I'm figuring out that, oh, this corner is actually quite weak. I have a bunch of windows in one corner. So I'm going to stiffen that up by requiring that device on that panel and on that panel. It's important to note those things, okay? So that said, the last thing we're going to check in the next video is the tall wall. And after that, we will be done with the lateral design.